The solution to this problem had a couple of flaws, got garbled, and ran on a little too long. So I'm going to go over it kind of quickly now. The problem, if you've seen the previous clips, is just x is the time to coast down an incline, y is the distance down the incline, acceleration is double the distance divided by the square of the time. I'm going to let that be our z. So z is equal to the acceleration is equal to this. F of xy is going to then be 2y over x squared, so that we can refer to the function and its partial derivatives in terms of the f notation. The situation on the graph is, looking for a pen here, okay, situation on the graph is that we have an observation x naught and an observation y naught. Now x naught y naught indicates an observation of x and y. For example, if our observation is x naught equals 3.6 seconds with an uncertainty of plus or minus 0.4 seconds, y naught equals 30 seconds with an uncertainty of plus or minus 2 centimeters. I think I said centimeters, 30 centimeters, uncertainty plus or minus 2 centimeters, then we expect that our x value will lie somewhere between 3.6 seconds minus 0.4 seconds and 3.6 seconds plus 0.4 seconds. That gives us an interval of the x-axis. We expect that if this is our precise observation, if we observe x naught, then that indicates an actual value somewhere between x naught minus delta x and x naught plus delta x, where delta x is 4 seconds, x naught is 3.6 seconds. Similarly, y is observed to be, let's say, 30 centimeters or whatever. So we have a y naught and we have a plus or minus a delta y. In this case, in this example, y is going to be y naught plus or minus delta y, with delta y equal 2 centimeters, y naught 30 centimeters. The delta x, or the x interval and the y interval, again, x is the interval within which we expect our actual time to lie, y naught the interval within which we expect our actual distance to lie. That gives us a rectangle in the xy plane. Now when you do sophisticated error analysis with Gaussians and so forth, you find that your region is really kind of an ellipse. It is an ellipse, but we're just going to use the rectangle. This rectangle has, if x is in this direction, has central coordinate x naught, and if y is in this direction, its central coordinate is y naught, and we have delta x and delta y on either side of x naught, delta y on either side of y naught, so that this region represents the inequality x naught minus delta x less than x naught plus delta x, and y naught minus delta y less than y naught plus delta y.